The effect of outliers is what we're going to have a look at next. Outliers are scores that lie out of the way, hence the word outlier, out of the way of the rest of the scores. So if I had a dot plot that looked like this, and that was say 2, 3, 4, 5, 6, and then here's 7, 8, 9, 10 and 11, and let's say I had one occurring up here at 11. This was obviously going to be an outlier. Now how do we get an outlier? Okay, well most of the time an outlier is a mistake. So it's an incorrect measurement. So either it's been incorrectly measured or it can be incorrectly recorded. So someone may have said I have 11, but they might have actually meant it was 11 and then it was 2, so really I'm looking at a gap of, I don't know, 9 or 5, or I don't know, you may have heard the word 8 but it was actually something else, or maybe you've wrote an 8 and it was meant to be a 6, so you've wrote a 1 and it was meant to be a 1 and a 1 but you've recorded it as an 11. So there are all sorts of different reasons as to why you may have an outlier, but most of them are incorrect measurement that was given or incorrect measurement that was done and an incorrect recording. Now most of the time we should exclude these, because if they're really sitting out there on their own and they're really a lot farther away from the rest of the data, then they're going to do nothing except for affect our results, affect our mean, they're going to affect our median, they're going to affect the average, and they're going to affect our range. However, that's why we use different types of effectors such as the median, or we might look at the interquartile range, which isn't affected by outliers. So if we have an outlier, what can they affect the most? So outliers affect the measures of location. They do affect the measure of spread, but really the only measure of spread they affect is the range, because instead of the range being 6 take away 1 was 5, the range would be 11 take away 1, which is 10. So it would give you a bigger range. But the interquartile range is probably the most accurate measure of range, and that would be the one that we would use most commonly, and it's not going to be affected by an outlier at all. So outliers affect mostly the measure of location. So remember, measures of location are your mean, mode and median. So the mean is most affected. And it's most affected because when we calculate the mean, we add all the scores up and we divide by the number of the scores, okay, or the total of the frequency. So the sum of the scores is affected. And generally it's affected because this outlier is either much larger or much smaller, and it's accounted for another score of exactly the same clarity, or exactly the same clarity, sorry, that's the wrong word, of exactly the same magnitude as the other scores. However, it's not sitting there. So 11 is a lot different number to a number that was ranging between 1 and 6. So it's most affected because the sum of the scores is affected by a really large number or a really small number in that adding up. The median is affected slightly, but little. So it's not affected very much at all. And the middle score is the score that's in the middle. So if, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So half of 20 is 10, 20 plus 1 is 21. Half of 21 is 10 and a half. So it's going to be about there is going to be my median. If I included my outlier, it simply means that that score will be my median. So it's really not affecting my median by very much at all. So if I do have outliers, the best measure of location to use is my median. Now, of course, my mode, this is totally unaffected because the mode is the score that occurs the most. And the only reason I would use it as a measure of location is if I had categorical or qualitative data, where I've got words that I can't choose any other, mean or median. I can't calculate anything because I don't have numbers or scores. So basically what the next exercise, which is exercise 4.04, is going to look at is the effect of outliers. So it's going to look at calculating the mean and the median and then saying what effect does it have on the mean and what effect does it have on the median and what effect does it have on the mode. And clearly it would be none of those for the mode. So if I did, for example, this question here where I've got a dot plot, 36 has 2, 37 has 3, 38 has 3, 39 has 5, and if I go up to 40, 41 and 42 has 1, and this is degrees Celsius. If I calculated the mean, mode and median, my mean, or x bar, is going to give me 534 divided by 14, which gives me 38.1. My mode, of course, is the score that occurs the most, is 39. And my median, I've got, it will be between 38 and 38, so it will be obviously 38. If I then said, what is the outlier temperature? Well, the outlier obviously is looking at temperature of 42 degrees, this one up here. And how is that now, if I calculated it by excluding my mean, my outlier, my mean would be 492 divided by 14. So you can see how significantly my sum has come down, which gives me then 35.1. And if you have a look at my data, 35.1 is probably a lot closer to being the average temperature. My mode stays exactly the same at 39, and my median again is only affected by another, and it's still 38, and obviously it was one of those three scores to begin with. So the high outlier does not affect the mode and the median, but it did definitely increase the mean significantly to be 38.1, which probably wasn't where the majority of the data was sitting. So I think you can now work on exercise 4.01, and given that exercise, I think you can probably work through questions question 2 through to question 6.